Okay, so here we go. My name's Mark Sainer. I'm the FR Technical Manager here at Workrite Uniform Company. And today I'm going to talk about some of the common FR material testing methods that go on out there in the marketplace. Get a little insight on those. Hope you get a better understanding on how the fabrics are tested for your particular hazard in the marketplace. So with that said, let's get started. The typical testing methods are either developed by ASTM or NFPA, depending on which standard you're talking about. So we're going to touch on a couple of those. We're going to talk about basic flammability testing, which is one of the key first things that all fabrics have to go through to make sure that they meet the requirements to be considered flame resistant. We'll also talk about the testing used to develop the arc ratings for those garments designed to be used for electric arc flash protection. And we'll talk about the mannequin test, flash fire mannequin test, which is a well-known test by most. It's used to measure body burn predictions for exposure to flash fires, fires from flammable gases, vapors, etc. And then also a heat transfer performance test, the HTP test, which is very specific to the NFPA 2112 standard. So those are the basic test methods we're going to run through. So first, let's talk about the basic flammability test. This test, as I mentioned, is one that's used by multiple standards. It goes by the name of the vertical flame test. It's an ASTM test method, D6413. It's used in standards like NFPA 2112, ASTM F1506, and NFPA 1975, and some others. NFPA 2112 being the standard for garments and fabric used for protection against flash fires, whether it be flammable vapors, flammable gases, combustible dust, any of those that might be considered in that realm. The ASTM F1506 is the standard for the electric arc flash fabrics and materials that's referenced by NFPA 70E. It's referenced by the National Electrical Safety Code, referenced by the OSHA 1910-269 standard for electrical utility workers, and then NFPA 1975, which is for fire service station uniforms. All those standards start off with this ASTM D6413 as their basic test to determine whether a fabric is considered to be flame resistant. And here's a little video of how this particular test is run. Whoops. All right, going to get my video to work here. Here we go. Click on the test and you can see there's a fabric swatch and a little flame at the base that's going to burn for 12 seconds. At the end of 12 seconds, the flame goes out, and that's the flammability testing. And there's a couple things that are being measured when that flame extinguishes. One thing is you're looking for after flame. Was there any after flame of the fabric continuing to have some flaming going on after the burner's been turned off? And most of the standards require that a maximum of 2-second after flame be involved. If you look at the char length, what you're measuring then is the part of the fabric that has been charred and broken. You take the fabric, you fold it and crease it through the center point of the charred area. You apply a small weight to one corner of the fabric, and then you measure the char length. And you can see in this particular case, it's about 3.5 inches of char length that's considered. Depending on which standard, the amount of maximum char length allowed will differ. NFPA 2112, for example, it has to be no more than 4 inches. For the ASTM F1506, no more than 6 inches. It just depends on which standard is, which committee has determined what the acceptable maximum char length might be. So you measure the char length, you look at the after flame. Those are the two basic criteria used for this ASTM D6413 test method to determine whether or not a fabric is considered flame resistant. Once you've crossed that hurdle, then fabric manufacturers can move on to do the other testing more specific to the particular hazard that they're developing the fabrics for. So that's first level, basic. Is it flame resistant or not? you'd use the D6413 vertical flame test. Now, when you move into the next phase, if you're looking at products that are protection against electric arc flash, all those fabrics have to have an arc rating developed for them. And in order to determine the arc rating of the fabric, it has to go through the ASTM F1959 test. This test determines the actual arc rating of the fabric material. That particular test is specified to be used in the ASTM F1506 again. It's referenced by the NFPA 70E standard because it has the fabrics and garments that are acceptable to that standard have to have an arc rating. 70E references back to the ASTM F1506 as the standard measurement for the materials, but NFPA 70E does require an arc rating, as does the NESC, National Electrical Safety Code, and the OSHA 1910-269. They all require that the fabrics used in the protective garments have an arc rating, and ASTM F1959 is the test method that's used to determine the arc rating. So I'm going to run a little video that shows an arc rating or an arc test being run. What you'll see are several panels. You'll see a close-up shot of one panel with the fabric on it, and then a very fast explosion. It just happens in a split second, but all those samples have sensors behind them that are going to read the heat flux and thermal transfer through the fabric onto the sensor. So this is what the unit looks like. You can see there's one to the left and to the right, and then the one in the foreground is actually a close-up of the center panel that's being read, and then down through the center is where the arc explosion takes place. So when that test is run, boom, you see the big arc flash, happens in a split second. You can see how it charred the one close-up shot. And as I said, each of those panels has a sensor behind it that measures the heat transfer through that particular piece of fabric. And with that number, then it's calculated, and a determination is made what is the arc rating or the arc thermal performance value, ATPV. That's where you'll see the numbers on the garments like 8.7 or 12.2 or 40 or whatever the number might be. That determines the arc rating, and that's measured in calories per square centimeter. The other abbreviation you might see occasionally is EBT. That's the energy break open threshold. So as you're running this test, and it has to go through multiple iterations to come to what the actual rating is, the fabric may break open. Rather than have an ATPV, it is then given the rating where at the level at which the fabric actually broke open. So that's considered an EBT. That's a break open threshold. That's the arc rating that's assigned to it. They're both arc ratings. One is when it breaks open, one is when it just reaches that rating. There's a 50% probability of a second-degree burn. So that particular test, as I said, is run multiple times for any given fabric to come up with the arc rating for the specific fabric, always measured in calories per square centimeter. It's a test that has to be run if there's any changes made to the fabric, whether it be in the weave, in the yarns, in the processing to make it flame resistant. Anytime there's a change, this test has to be rerun to validate the arc rating of that particular fabric. And that's what you'll see on the garment. You also see oftentimes the NFPA 70E category 1, 2, 3, or 4, and those are associated with the arc ratings as well. Category 1 has a minimum of 4 calories requirement. Category 2, minimum of 8. Category 3, minimum of 25. And Category 4, minimum of 40. So there's arc ratings, there's the NFPA 70E PPE categories 1, 2, 3, and 4. Both those are key elements when you're looking at arc protection for electrical workers in the industrial arena. The next test method is the flash fire mannequin test. This is one that if you're in the hazard zone where you're going to have potential for a flash fire from a flammable vapor, gas, or combustible dust, This is a test that's critical to be run, and one that's a pretty famous one. And it's primarily only used in NFPA 2112, the flash fire fabric garment standard. And it's a test that's run in live conditions with flames. It's not a flash fire, but it generates the type of thermal exposure that is expected. It's run at 2 calories per square centimeter of heat flux. It's run for 3 seconds in requirement for NFPA 2112, and then it's measured to give you some kind of a predicted body burn percentage based on the testing and run up against the skin burn model that's as part of the calculations for the predicted body burn. And here's a sample. You can see the mannequin is dressed in a standardized coverall in the middle. It's got multiple burners, propane burners around the perimeter that have been calibrated to produce the right amount of heat generation, and then it is run. So when we run this test, you can see the flames kick on. The mannequin is fully engulfed. It has multiple 100 plus sensors underneath the mannequin, and those are reading the heat flux transfer through the fabric, which then goes to the calculation to give you some kind of a predicted body burn. This is an example of the kind of readout printout that you get after running the test. You can see on the diagram on the left, it's a silhouette of the mannequin, both the front on the left and the back on the right, and it shows the exposed areas that have received either no burn, second-degree burn, or third-degree burn. Now, the hands and feet are black because they're not censored, so there is no measurement there. The red areas on the right arm on the front, right arm on the back, the right leg down around the calf area, a number of places, as well as the head, all show second or third degree burn. Now the head is going to show third degree burns for obvious reason. It's not covered with the coverall, so it's going to get third degree burn. And that's in generally, depending on which mannequin is being tested or which test site, it's going to be in the 6 to 7% of the body burn prediction is going to be based solely on the head because it's unprotected. In this particular example, you can see I've circled 38.5. That's the predicted body burn percentage for this particular test run on this particular coverall fabric. So that's how that one's run. It's kind of a cool test. You get live flames being burned. It gives you some kind of a predicted. It's not going to represent what's going to happen out in the field necessarily, but it gives you some way to gauge how this particular fabric. Now in the NFPA 2112 standard, it allows for up to a maximum of 50%. So in this case, the 38.5 would pass. We see body burn numbers down in the teens. You can see them up into the 30s, low 40s, but any of those would be a passing grade for the NFPA 2112. The next test that's not quite as well known as some of the others is called the Heat Transfer Performance, or HTP test. It's ASTM F2700. This one is previously was used in NFPA 2112 in a little different manner called the TPP test, which people may have heard of. And it's basically exposing the fabric to a combination of radiant and convective heat. When you look at and I don't have a video on this one, but when you look at the apparatus, you can see down on the bottom side, you've got some burners and some flames going on down there producing the 2-calorie heat flush exposure, again, with both radiant and convective heat. And you're measuring the heat transfer through the fabric, which is in the center, up through onto some sensors. And again, you're measuring it over time against a curve that shows when you're going to get some burn injury. You can look on the right-hand side and you can see that there's a photograph of a sample fabric that was actually tested. The little burnt square chart area is where the heat, both convective and radiant heat, were exposed to the fabric. And there's two different measurements that are required by the NFPA standard. One is what they call spaced, and the other is called in contact. Contact means that the fabric is down at the level of the plate. Spaced means that the fabric is raised up a bit off of the plate to give a little more gap in there. And both have a requirement in the NFPA 2112 standard. When you're looking at the spaced configuration, it has to have a minimum of 6 calories, and in the contact, a minimum of 3 calories. Again, just one more measurement to make sure that the fabrics being used for that NFPA 2112 standard are in compliance. You've got the vertical flammability test, you've got the mannequin test, and you've got the HTP heat transfer test, all of which have to be passed in order to be compliant with NFPA 2112. 4-inch char length for the vertical flame, maximum 50% body burn for the mannequin test, and then 6 and 3 cal HTP ratings for space and contact. So those are the requirements for 2112. The arc flash, slightly different, doesn't require the mannequin or the HTP. So that's pretty much how the main basic tests that are being run in the market today for flame resistant fabrics. Again, arc flash, you've got flammability, vertical flame, and the arc rating, and then flash fire, vertical flame, mannequin, HTP. There are other tests. NFPA 2112 also has an oven test, heat and thermal shrinkage. There's a number of tests that can be run. Fabrics have tensile and tear strength tests that are run. There's a color fastness test. A lot of different tests can be run, but those are the primary heat and thermal type testing that take place on the flammable garments. This presentation is being recorded. It's going to be on the Workrite website sometime in the not too distant future. You just need to go onto the home site, click on the Workrite Interactive. That takes you to the interactive page, and then you click on the FR Live, and that'll take you to where we have both simulate or shows what's going to be coming up next and what's going to be in the archive. So we'll have another webinar coming up sometime in the next several months, which will be posted on our website. So we appreciate you coming today. We look forward to having you back on future webinars. There's other information also on the website, blog posts, a lot of good technical information in our FR Essentials page, and we think it's a lot of good information to be out there to help you. So appreciate you being here. If you have any questions about this or other FR topics, feel free to shoot me an email at msainer@workrite.com. I'm here to help. Hope we can keep you up to speed on what's going on and make sure everybody has a safe work day and our products are out there doing the job that they're designed to do. So appreciate you being here, and we'll look forward to seeing you in the future. Thank you.